Hello? Can you guys hear us? Yeah? All right, great. Yeah, hi everyone. My name is George. I'm engineering manager in ML platform team at Volvo Cars. This is my colleague Steve.
Hello.
Today we're going to talk about Abacus, which is the platform we've built internally at Volvo. So today, anyone, just within a couple of minutes, can onboard to ML platform, spin up notebook server, start validating their idea, and without approvals, without any waiting times, without a man in the middle. And since we've built it on top of Kubernetes and cloud native stack, we thought this would be a perfect venue to share our learnings with you. And I'll hand it over to Steve to talk a little bit more about the platform.
OK, thanks, George. So this is our technology stack. The platform itself, Abacus, is the top layer here. And these are the components that we're going to talk more about today. However, before we start, we'd like to acknowledge the other developer platforms at Volvo Cars on which we've built. Most notably, as a small team, we benefit greatly from the common enterprise container platform. This is a common code base which deploys a number of Volvo Cars Kubernetes clusters running a myriad of the company's workloads. This allows us to focus on our primary concern, which is ML. As you can see, we're fond of open source and cloud-native technologies. And Abacus is built on the Kubeflow ecosystem. We've added other products here to either complement Kubeflow or to integrate with the corporate network at Volvo. So let's set some context first by looking at some numbers. This gives an overview of the type of scale at which we're working in our company. The highlights here are that we have approximately 200 monthly active users. We have been running production workloads for around 3 years now, including some at the start on a non-production cluster, which wasn't great. But the figures that we are most proud of here are those around the community. So we use Slack for both announcements and for support. We believe in transparency, and so we solve our support issues out in the open, and it's the engineers who build the platform who are talking to the users. So we don't have any first or second line support. This is really good because it creates a bond between the engineers and between the users. So we see that some users, they even help out with the support requests of others. We also have 48 contributors to our inner-sourced repo. And we promote that anyone within the company can suggest a change simply by uploading a PR. So that's a little bit about where we are today. Let's take a look at where did we start from. So this picture is probably fairly familiar to many people working with ML today. So we won't dwell here for too long. In short, at the beginning, we had almost no support for our data scientists. It led to a scattered technology landscape. People were working either individually or in small teams, often solving the same problem over and over again. Without a common development process, we risked having a lack of reproducibility and a lack of traceability from ML model back to the code, data, and parameters used to create it. While the undertaking to build a common central platform in a large enterprise such as ours is not always the right solution, in this case, we think that by doing so, we've been able to bring our diverse community of data scientists and analysts together. We have built an active community around the platform. We've led people into common practices without being too rigid. And we are able to solve common problems once, such as the integration into the company's network while following the prescribed security standards. So let's have a look at how we've approached it. This is the big picture of Abacus that we're going to talk about today. Previously, the users had to start with a blank canvas. This made it very difficult for them to know exactly how to get started. And that's what led to the fragmentation and the siloed way of working. There was a lack of common practices, and there were no templates to help them get started. Experience also told us that if they were able to build an ML model, then going into production was really, really difficult. And there was no support available for the feedback loop used to create successive iterations of the model. So we divided the life cycle into 3 stages. And we talk about 3 separate user journeys. The first mile, which involves onboarding to the platform and creating new projects. During day-to-day usage, which is either producing insights or training ML models. And then the last mile, in which people can take their trained ML model into production and then continuously monitor its performance. So we'll talk more about each one of these 3 stages in the next 20-something minutes. But first, we'd like to reflect a little bit on the day-to-day life of us platform engineers. So at the start, we saw the platform as a large tech stack style picture, representing a subset of the CNCF landscape. Here we show how each of these individual projects is linked together to solve some task. But if we take away these arrows, then we can see the same set of projects we saw in the beginning. And whether we install these projects with GitOps, with Helm install, with kubectl apply, we believe that this is the easier part of this process. When we first started, we even installed many other projects, such as the Volcano batch scheduler, a long time before we even knew whether we needed them or not. But if we only look at the arrows, this shows the integration of all of those software projects. This is used to accomplish a task or even build the development process around which our data scientists work. And this is really what helps us solve the illities that we saw on the common challenges slide earlier: reproducibility, traceability, and visibility. This is where we introduce some control, while at the same time allowing for the flexibility so that we're not being too rigid. So if we now go and zoom into the first mile, this is the onboarding phase, and this is where we have the first touch point with the user. So we want this stage to be as frictionless and seamless as possible. We direct all users to a single URL, and that's where we have the Kubeflow dashboard. And we've configured Kubeflow so that whenever they visit the dashboard for the first time, they're onboarded to the platform. Here we've also patched the Kubeflow profile management components so that we can integrate our own onboarding application into the flow. And this application creates all of the resources that our users use. So it creates the Kubeflow profile and the Kubernetes namespace. It creates a GitHub repo that's generated from a template that's set up well for data science. We create a container image registry, a Vault secret store, and a repository in LakeFS, which is an object store that provides good support for versioning of data. We also provision the CI infrastructure used to build the Kubeflow pipeline components, and we use Tekton for that. Finally, we also create an Azure AD group, which is how we integrate into the corporation's identity and access management system. And that's used to gain access to all of these services. The result of this process is that the user receives an email, which is above my head here, and that contains all of the links to those services, so they can easily get started. And at this point, they can launch a notebook server in a personal sandbox. And from there, they can start to explore the platform. So from the user's perspective, what they see here is that they're able to manage their profile, either first-time onboarding or creating subsequent projects, and to get access to the service. However, from our perspective as the engineering team, what we see is this is the tip of the iceberg. If we look below the waterline, we're handling all of the enterprise integration. We provide comprehensive documentation, including tutorials and getting started guides. And we ensure multi-tenant isolation. So we deploy the network policy and the Istio authorization policies that mean that users can't see each other's namespaces. And we deploy this infrastructure with GitOps. Finally, we also enable FinOps right from the start, as we'll see now. So this is the Kubeflow central dashboard. And we've tailored this to match our color scheme. we've included links to our documentation and to our Slack support channel. We've also added a card here right in the UI that shows the cumulative costs for the last 30 days. So by surfacing this information in the UI, the users can be a lot more cost conscious. We also added the ability to create a new project from right here from the UI. So let's have a look at that. So this is the new project page. If we click start, we can enter a name. We can say KubeCon EU 2025. We can set a Python package name if needed or skip it. We can select the tier, which George is going to talk about in a minute, and the minimum Python package version. That's used to set in the generated source template. We won't wait here until the 40 seconds or so that it requires to create the namespace. So to summarize what we've learned by building this onboarding flow, at the start, we see that people act responsibly whenever they see the costs. So it's really nice to see that our colleagues are really cost conscious. And even if the monthly cost is less than a cup of coffee in some cases, they often ask us to offboard from the platform in order to save that cost. And we think that that's because we've made the onboarding flow very seamless and frictionless, so that some people will say that they want to offboard, and then they'll come back again whenever they want to use the platform. We also learnt that we should have contributed our patches to Kubeflow. We were aware of this at the time, but the time pressures of getting into production, we decided that the contribution process and reworking our patches to be more generic would have taken too much time. Given that we already have workloads running in development now, we decided to prioritize going to prod. However, several years later, we think it's high time to pick up on this and to start to contribute them back. We have contributed several small patches to the project, and we found that the process was both welcoming and seamless. So we definitely recommend it. And finally, we built our onboarding application as a service calling out to other services to create those resources. If we were to do that today, we would have chosen to use the operator pattern so that we have the reconciliation to keep those services running. We were aware of that at the time, but again, we decided to prioritize going into production, and given the experience we had in the team at that time, having a simple application calling those API endpoints to set up the services, we believe that was the right call at that time. So with that, I'll hand over to George. He's going to continue with the day-to-day work.
Thanks, Steve. OK, so now that we've passed the first mile and we onboarded to the platform, it's time for day-to-day operations. And this is where the most work is happening for our users and for our team as well. If we take a look at the diagram, we see two boxes there annotated with insights and ML product. So what are those? Early in our journey, we've discovered that if you add too much functionality and give too much to the user, they find it overwhelming. And especially yesterday, they were working in the comfort of their local environment with the notebook servers, and the next day, they were thrown into Kubernetes world with deployments, pods, authorization policies, and whatnot. And it was a little bit too much. We did have users, early adopters as well, of course, that loved this and loved experimentation. But in general, there was some resistance. So to address that, we try to, first of all, abstract away Kubernetes APIs as much as possible, but also to introduce this functionality to them in a gradual manner. So we've split the ways of working into two tiers. So we call them insights and ML product. So we provide a subset of functionality and features depending on the goals they're trying to achieve. But in both cases, they get some baseline to get started with. Like, for instance, a repository from a template and UI via Kubeflow UI. Now let's take a look at each tier individually. First one is the insights. It's the more lightweight alternative out of two. Everything we do starts with a source code versioning. So in the onboarding, we're creating a GitHub repo from standard template, which structures their code after Python package, and it also adds some boilerplate for unit tests and integration tests. Every project that onboards to the platform has the same structure. So it makes support, troubleshooting down the line much, much easier. Users then clone their source code into the notebook servers, and yeah, they start working the same way they were working before on the laptops. We pre-built notebook servers with different packages, CLIs, connectors, depending on what we're trying to do, which are common to most of the users. But some users also create their own notebook images and contribute back to the platform. So the way they do it is basically a pull request with a Docker file, and then CI, Docker file to our repository, and then CI takes care of it. It builds the image, it tags it, it uploads it to Harbor image registry, and then makes it available to everyone else. They also get a Spark cluster, and they can schedule Spark jobs from notebook servers, but we find that most of the time, they get away with much lightweight tools with better APIs, like DuckDB, for instance. We've done a lot of legwork initially to make sure that the platform is well integrated within the network at Volvo Cars and has access to most of the data sources. But at the same time, we also provide the Git-like data versioning with LakeFS, which we integrated really nicely, or natively, one might say, within our platform. So this tier provides balance of simplicity and just enough reproducibility and functionality to do the exploratory data analysis, I don't know, some other kind of analytics or reporting or a dashboard. And that's what is used for most of the times. Yeah, so now the idea has been validated. We are past the ADA stage, and it's time to add some automation and give it a bit more of a production look and feel. Here, users can upgrade seamlessly the project that they already had with one pull request again, or they can start a new project the way Steve demonstrated in the UI and have a project on the ML tier, ML product tier. It is also worth mentioning that this tier extends the previous one, so everything you had before you have here as well. We didn't add the icons to make it a bit cleaner, but then we built on top of the existing functionality. So first of all, we upgrade the repository to hold manifest for arbitrary applications of Kubeflow pipelines and Kubeflow components. So whenever they make a commit to their repo, it sends the payload from GitHub webhook to Tekton, and in the CI cycle, then we build the components for them. We tag them with commit SHA. We upload them to Harbor image registry. Then we also build Kubeflow components and we compile Kubeflow pipelines. Again, tag them, upload to Kubeflow. And yeah, from this point forward, they are working in already now familiar environment of Kubeflow, where they use training operators, hyperparameter tuning with KTIP, of course, Kubeflow pipelines, where they do a lot of data processing work, and then eventually some of them deploy models as well from the pipelines as a K-serve inference service. And here we would like to emphasize the importance of the CI, because if you're just starting, you read the documentation and let's say Kubeflow docs, and you have a lot of this nice small examples of creating container from function or using components, but how to build those components is left up for the user. So if you build a component, you need to make sure you tag it, you need to upload it to the registry, you need to update the references of the component in your Kubeflow pipeline. You need to compile it. You also need to upload that too. So it becomes very cumbersome and obviously very error-prone. So that's why it's very important to have, first of all, a standard structure that every project can reuse, and also this rigorous approach to do all these steps in automated and standardized fashion. And that's exactly what we provide in this tier. We provide the standardization, and we support everything from the first commit down to the inference service. And yeah, there are a few learnings we can share here. Like, first of all, it's very important to start simple, right? Do not overcomplicate things. Don't try to provide all the bells and whistles from the day one, because it will become a little bit overwhelming to the user. And yeah, the adoption of the platform will also drop or will be slow. Then you need to design for different personas. You need to keep things simple and add functionality gradually, right? Not everyone will have a project with a model in production. Many projects are, about the hypothesis testing or about the idea validation or, reporting and so on. And you also have different users from different parts of the organization. So they might have a little bit different approach to how they work. Yeah, and it's also, when implementing this functionality, it's very important to balance the freedom, how much freedom you give on the platform versus how much restrictions you impose on it. Because, again, freedom to do whatever you want will leave your user in the state of blank canvas, as Steve pointed out, and it kind of defeats the purpose of having the standardization in the first place. And also it can pose all sorts of issues, like, for instance, unintentional network opening, right? So you need to be opinionated in the way you do things. Like in our case, if the user wants to create a service entry, they need to create a pull request on our repository, and then one of our engineers will review it, and then it's merged. And since we have pretty good support in Slack channel, this takes just a couple of minutes from request to the merge. And last but not least, the CI is really more difficult than it seems, because given the multidimensionality of ML space, right, you need to keep track of your code changes, but you also need to keep track of data version, of your model version, and any artifacts that you might produce or might use. So you really need to take a step back and think about how you want to implement the CI to keep track of all these things. And I don't know, maybe the first good step is to have a .dot file in the repository where you keep the references of the versions of these artifacts, and you update them in the CI cycles. All right, so now we proceed to the final stage. So we have the models we're happy with, and we are ready to deploy them in production. I'm sure everyone is aware, and I hope agrees, that handovers are not great, right? So that's why it was very important to us to make this transition from previous tier to production as simple as possible, as seamless as possible, so that users can truly take the end-to-end ownership of the entire life cycle of their project. And that's why the change from previous stages really very minimal. There are two things that stand out here. Like, first of all, there are no inference services deployed via Kubeflow pipelines anymore. All of the manifests they have for the applications or for the inference services are already in their GitHub repositories from the previous stages, and now everything is deployed via Argo CD. When they want to roll out new version of the model or the application, they just bump the tag. So we make a pull request on the repo, merge it, and that's it. We also learned that many users deploy both Kserve inferences and like fast API alongside it. They do some pre-processing before they send payload to the model, or they simply add the UI layer to it. The second noticeable difference here is the monitoring, is the bottom box there. One of the requirements we've put on ourselves is that this system had to be very flexible and extendable. And that's because many teams already have their own subscriptions, like storage subscriptions, right? So we wanted to provide this option for them to bring their own storage for monitoring as well. So they would be able, to just plug it in, so to say. Right, so we've created a login service that receives cloud events from Kserve, then correlates inputs and outputs of these events with the X request ID header, and then ingest them into the storage of their choice. And yeah, this approach has proven to be very useful because users have full control over how they want to share the data and with whom. And they also have the ability to bring any analytics tools if they want to and work on the data directly. And of course, we also have alerting in place. So from Argo CD, if the services go out of sync, we send Slack notification to their Slack channel. And also from the monitoring service, if there is a model drift, for instance, we send notification to their Slack channel. We have the usual suspects with Prometheus and Grafana to visualize metrics. And on top of that, we have teams get the ingress and end-to-end encryption, TLS certificate renewal out of the box, right? So they don't need to think about it, and they probably don't even know this is happening. It's just there in the background with Istio. So what have we learned from this stage? Look, first of all, few ML products get into production, or through ML models get into production, right? And it's quite natural. Like, first of all, to begin with, not every project has the goal to have a model in production, right? We've already talked about this, but the ones they have the EDA stage first, and have hypothesis validation. They need to test it, and then it doesn't make the cut. Yeah. The GitOps is very important, and it was not news to us, but yeah, the moment users see it in action, it completely changes the way they see things. First of all, it removes the overhead from them of deploying anything manually, but they also love the reassurance of things kind of auto-healing, right, or spinning up if something goes south. And production is an iterative process, right? It's not the stage that you reach and then you call it a day and it becomes someone else's problem. It's an iterative process where users need to maintain the model, they need to monitor them, retrain them, redeploy them. And that's why it is, again, very important to have this seamless transition between these stages so that you don't have this, big bang handover or whatever. Yes, and users need to have an environment where they can test their models safely from, further from the day-to-day work, like from the production workloads. But you also need to have an environment where you can safely try new features, upgrade components, upgrade cluster without interfering with user workloads. So there are a couple of ways to do it, right? Like, first of all, if we think of user, you can have two namespaces for them, one namespace for production workloads and inferences, the other one for day-to-day work, and they can just make releases to the production namespace. The other option is to have a dev cluster, where they have disparity, they run the same things in both clusters, and then you can make upgrades and observe if it causes any breakages for the user. And if it's not, then obviously you proceed to production cluster. Or you can have both, right? So in our case, we have both. We have dev-prod namespaces and dev-prod cluster as well. So to conclude our talk, I'd like to emphasize and reiterate over a couple of points. Like, first of all, if it was not clear enough and explicit enough, integration takes much, much more time and effort and energy than installation. You can Helm install, kubectl apply new tools, and have a nice example up and running fairly quickly, but it's nowhere near when you need to do something in production and have a production-ready system, because you need to think a lot how these components interact and work together within your platform, but you also need to think how you integrate the platform with the rest of the company's ecosystem, with all the restrictions that might be imposed on you. Then, once you have the platform, you need to think how you maintain it and how you grow it. You might have all sorts of projects with different use cases, with different requirements that you have not thought of, and then you need to be able to add new functionality or swap the components that you already have. Oh, we're running out of time. Yes. Yeah, I'll wrap it up then. Basically, you need to build a community around yourself, and you need to treat your platform as a product, because at the end of the day, that's what it is, right? You have a platform as a service where you have users running their workloads, so you need to do a product worked a little bit. And you have this capacity with your engineering team, then that's excellent, because you have engineers that know the product, know the user, understand the pain points, and know exactly what needs to be done to make it better. And if you have a good community around you, then you can all grow together, you can learn from each other, and just help each other out. With that, I would like to thank you, and I hope you enjoyed the talk. Good? Yeah.
Well, thank you very much for today's talk. I think you left the best for the last day, so very, very nice. I've been working with Kubeflow in my company for 4 years, and I have this added responsibility of building the pipelines, of building the inference services. So we have a little bit less time to work on only the platform. This is like part of the stuff we do. And I found this part that you did at the beginning where you, you customize even the creation of the project, sending them an email, like this GitLab or GitHub templates. Is that something you're thinking of, like open sourcing now that you're looking into, more into the community? Because that will be something that would be amazing for us. And even changing the color seems silly, but it gives us this personalization aspect, and I think it's really inspiring, by the way. And thanks a lot.
Yeah, we've been thinking about it, and we would love to do it, but what Steve pointed out is that it's not as it's kind of tightly integrated with the onboarding application that we have,
right?
But we maybe can try to open source both. Right, and then it will be like a package of creating the project from the UI, but you also have a backend to do all these things for you.
Yeah, or even like some blog post that gives the recipe of this is how we did it, because you have this knowledge, and I don't think I haven't seen this to do how the steps. So that will be awesome.
Yeah, of course.
Thanks a lot.
Yeah, thank you.
Thank you.